Welcome to Brain Vision.
Let's find the derivatives here using the chain rule. So as usual, I like to draw the tree diagram here to help out with the chain rule formula. So you see z depends only on x and y. That determines this part of our tree. But then over here, we see that x and y are both functions of two variables s and t. So now we go ahead and let's use the curly operator here because there are different variables here, s and t. So how do you go from z to s? Well, there's a few ways to get there. One is if you go from z to x and then x to s. And you could also go from z to y and then y to s. So we'll add that in too. So excuse me here, that should be dz over dy, dy over ds. And then before we go to the other partial derivative, let's just go ahead and compute this. So derivative of z with respect to x, you can just use the power rule over here. So I guess I'll just start writing that in now. So that's 5 x minus y to the fourth power, dx over ds, use the power rule here again. And then dz over dy, this time you'll use the power rule, but you also, when you use the chain rule, you'll get a -1 here. And then derivative of y with respect to s, that's just t squared. So perhaps we can just clean this up a little bit. So that's one of our answers there. Derivative of z with respect to s. And then now we look at the derivative, but this time with respect to t. So to go from z to t, you go from z to x, x to t, that's one way. And you could also go from zy and y to t. So we've already did two of these derivatives in the previous line, so we don't have to redo these. So that'll give us 5 and then x minus y to the fourth, and then dx over dt, that's just s squared. This one we already computed up here. But then now we'll need derivative of y with respect to t and use the power rule there to get 2st. And then perhaps here you can just simplify what you can. So 5s squared, x minus y to the fourth, and then minus 10 st, and then x minus y to the fourth. So this is our other partial derivative, and that completes our answer.